Hello. In this episode of Heirs for Architecture, I speak with Henrik Schoenefeldt, Professor of Sustainable Architecture at the University of Kent, and currently lead on the AHRC-funded project Between Heritage and Sustainability, restoring the Palace of Westminster's 19th century ventilation system, which feeds into the Palace of Westminster's Restoration and Renewal Programme, and which Henrik published as a book, Rebuilding the Houses of Parliament, David Boswell Reid and Disruptive Environmentalism, and published by Routledge in 2020.
A is for Architecture, a podcast about architecture, buildings, urban culture and space.
Hello and welcome to another episode of Heirs for Architecture. I'm talking today to Professor Henrik Schoenefeldt, colleague of mine at the University of Kent, about his book and project Rebuilding the Houses of Parliament, David Boswell Reid and Disruptive Environmentalism, published by Routledge in 2021. And we're going to talk about your project there and the book and some aspects of that. But perhaps before we go on, would you be so kind as to introduce yourself, Henrik?
Hi, Ambrose. I'm Henrik Schoenefeldt, and I'm actually Professor of Sustainability and Architecture Heritage at the University of Kent in Canterbury. And since completing my PhD in Cambridge in 2011, I started working on understanding the history of the Houses of Parliament from an environmental perspective, but also seeing how that history can offer insight that can help us to address questions of sustainability in the 21st century, and especially in the context of the forthcoming Restoration and Renewal Programme of the Palace of Westminster.
Fabulous. Ever since I've known you, since I came to Kent in 2018, you've been working on this project. Where did it come from? Obviously, there's a quite expensive restoration project going on there. How did you come to be involved?
It started off in some ways in a modest project. So when I finished my PhD in Cambridge in 2011, and then I arrived at Kent in the autumn 2011 to start here my role as a lecturer. And the first thing that I did in terms of research was to actually looking at some original archival material relating to the environmental thinking behind the Palace of Westminster. Because when I was doing my PhD in Cambridge, it wasn't on the Palace of Westminster, it was actually on glass architecture. The history of glass architecture from an environmental point of view is in that context that I stumbled across a lot of references to the Palace of Westminster being this technologically innovative building, particularly in terms of ventilation and climate control ideas, and that its architecture was shaped in substantial ways by those ideas. So that made me very curious, and essentially pretty much from day one, I started just doing some preliminary research into this. So purely as an academic exercise initially to lead to a series of smaller publications in journal articles. But then coincided with the time when the early inquiries happened in Westminster about the restoration and renewal. So there were actually two committees, two commissions, actually, the House of Lords and the House of Commons, who were looking into a way forward with this project of what needs to be done to upgrade the 19th century Palace of Westminster to meet 21st century demands, so addressing questions such as fire safety, accessibility, but especially building services. So a particular renewal of building services in that building, which are really outdated now. We're talking about now modern building services rather than the original ones that were established as the building was built in the 19th century. So it just was a fortunate moment where actually that research suddenly became relevant, even at that very early on in the beginning. And through that, then I built a relationship with the people in Parliament who were involved with the Restoration and Renewal Programme. It started off as a very small program, only a small group of people involved at that stage. And I produced a report for the House of Commons Commission to outlining why it's important to look back at the original design of the Palace of Westminster from a point of ventilation and climate control perspective, because the building was designed around these principles. And whilst that was generally known that that was the case, the system itself wasn't understood in any great depth. So that really opened up the opportunity of a project that not only to open up a new understanding of a very significant heritage building with the World UNESCO Heritage Site. I might be surprised that even buildings are so famous as the Palace of Westminster, that actually a lot of aspects of buildings are not very well understood or researched. And I find that remarkable. So I use that really as an opportunity to do a deep dive kind of research project to understand the environmental dimension of the rebuilding of the Houses of Parliament. And what is maybe quite distinctive about this research is, in order to do this kind of research, it's incredibly meticulous, because you need to go through thousands of historic documents to reconstruct essentially the development of its design and understand how the people were thinking about these problems and what their objectives were. And historians generally don't have the technical background to necessarily fully grasp the significance of some of these sources, because you go literally looking. So one thing that I've always been quite interested in is understanding how these systems actually performed when they were in use. So looking at lots of numerical data, analyzing the numerical data, and trying to get an insight into actually how well did these systems actually perform. And one important thing is to highlight maybe here is there's a lot of literature on the Palace of Westminster and the House of Parliament that looks at its architecture. And in this architecture, the contribution of David Boswell Reid has always been dismissed. So we see even in a more recent book, one like Caroline Shenton's Mr. Barry's War, where Reid is described as this crackpot inventor. So somebody was not given really credit for his contributions to the design of the Palace of Westminster, but just portrayed as a kind of problem to the delivery of the building. Because as you might be familiar with, when the building was rebuilt after the fire, there was a big fire in 1834, the competition was held that David Boswell Reid and Augustus Pugin won. That in that in that project, to deliver that project, so the architect took much longer, the budget overran enormously. And this is something that Caroline Shenton in her book does investigate in quite a lot of depth, but it doesn't really give credit or try to illuminate a little bit about the role of this physician called David Boswell Reid in its development. But I think it's absolutely fundamental to understand the nature of 19th century public building design as it was evolving in that early to mid 19th century. Because it was kind of formative years, because there were lots of technologies that were quite infant, so in the infancy at the time, and particularly applying technologies such as stack ventilation to a very large scale building was quite groundbreaking ideas.
Before you carry on, and thank you for that, it's very, very interesting, and we'll come back to some of that in a second. I wanted to go back into your own biography a little bit, because you did your PhD under Dean Hawkes.
No, not under Dean Hawkes, by Alan Short.
Okay.
Professor Alan Short, who is now retired, but he was a professor of architecture.
Okay. But you've mentioned...
I know Dean very well. He's a friend.
But you've mentioned this idea of environmental thinking, which I'm kind of really interested in, because it seems to underpin a lot of what you're talking about, which is, as I understand it, a more holistic and integrated idea of environmental design than perhaps certainly in architecture schools, generally speaking, we teach, which is okay, but can be fairly superficial, can be fairly technologically grounded, or environmental conditions are technologically solved and then we leave it at that. But what you're talking about here, from what I picked up from what you've said and from the book, is something that's a lot more of an integrated and fundamental approach to the role of environmental performance in the production of architecture. Is that right?
Yeah, that's very much. And one thing that might be worth highlighting here, and that makes this point in the book in some ways, is making this distinction between what we maybe call engineering and science.
Okay.
Because what David Boswell Reid contribution was, I would say, is a contribution to building science and the application of building science and the fundamentals to architecture. So he, in some ways, although we might consider the building technologically advanced, but actually, from a ventilation point of view, it is not actually about mechanical technology. It's about understanding the natural behavior, for instance, of air, of different densities. So if you have a tower and you have warm air, it rises up the tower and pulls air through the building. So that is essentially utilizing building physics and then using architectural elements such as the tower to enable that convection to happen, so hot air to rise up a shaft and therefore helping to propel the air through a building, rather than relying largely on mechanical fans, let's say steam-powered fans, which we typically associate with the Industrial Revolution, the technological revolution that happened at that time. So the emphasis really is on him, on starting with the building physics. And I think that's probably a lesson for students today, and even practicing architects today, even conventional practices, can learn from, is that actually environmental design should start with the architecture before it draws on technologies. And I find the Palace of Westminster in some ways illustrates that actually the most lasting elements of David Boswell Reid's systems are those that are integral to the architecture. The towers, the hollow walls that contain the flues, the air channels. So everything was architectural of the system. So when it had, within it, of course, it had steam heating systems, let's say, and warm water systems in it. It had some fans in it, but they were actually quite a minor feature of that system. A lot was to do with actually what is inherently part of the architecture. So the architecture of ventilation. And that shaped the building fabric in lots of ways. The external form is really completely shaped by them in really fundamental ways. So the big spire that you see above Central Lobby would have never been built if it hadn't been David Boswell Reid proposing the idea that the building should have a central stack system. An idea that was never quite fully realized, but it was this ambition to literally use the architectural elements that then Charles Barry, the architect, was embracing in some ways, of helping to make this building, heighten the building's architectural qualities, its picturesque effects.
I'd like to understand more about this man, David Boswell Reid, because as you've mentioned, the architects Barry and Pugin get all of the plaudits. They're the heroes, certainly for architects. You know, we are a discipline that's addicted to heroes, and big architect heroes more than anything. And the idea of this eccentric Scottish physician coming down and being integrated, this scientist, as you've suggested, is really interesting. So who was he? Where did he come from? And what was his background that made him available, I suppose, selectable as a design innovator within that trio?
So he essentially, David Boswell Reid was based in Edinburgh. Mm-hmm. So he was based in Edinburgh, and he's medically trained, but had a particular interest what was described as practical chemistry. So practical chemistry today we would probably describe it as applied chemistry.
Can you just tell me the dates of this? What are Boswell Reid's dates?
So this work, really we really think about the early 19th century. So this work starts in the late 1820s when it gets interesting.
Okay.
And then it's starting to really crystallize in the early 1830s when he's starting having his own teaching laboratory up in Edinburgh, where he's starting to develop his own curriculum. So he was actually writing textbooks on chemical chemistry, practical chemistry, for medical students to learn the science of actually doing scientific experimentation, but also seeing how the scientific experimentation can be applied to real world problems. And that's where his interest came, is particularly this idea that you can use that understanding to develop new ways of ventilating rooms. So you build model rooms in his laboratory to test ideas of stack ventilation and creating controlled climatic condition within those rooms. And using those basic understanding of practical chemistry, essentially, to understand ideas about air quality, ideas about thermal comfort. So he did a lot of research on air quality and thermal comfort as a fundamental challenge in building design. And he was exploring this purely in an experimental way, but from first principles in his laboratory. And it's through that he developed a sort of reputation as someone who was actually working in this field of ventilation. And there were a lot of public buildings in the 19th century, in the early 19th century, that were criticized for their poor ventilation and poor comfort. So you see that in John Somer's Law Courts buildings, for instance, in Westminster, from the 1820s, where you find lots of eyewitness accounts of the time talking about how uncomfortable they were, the air quality being poor or them being thermally uncomfortable. So what David Boswell Reid tried to do is to look at these problems from first principles and experiment with them, building models, full-scale models where students get involved in testing the controlled environment and asking them how well they experience the environment within those rooms. So those fundamental research eventually attracted interest of a specialist select committee that was appointed just at the same time that they were thinking about calling an architectural competition in Parliament. So that was in 1835. And the specialist select committee invited the experts of its time. So David Boswell Reid was one of them. So there would have been others, like John Sylvester, for instance, was someone who was really interested in central heating technologies, for instance. Neil Arnott and other engineers working on central heating systems, etc., were asked to advise them how could you design a public building where these questions of acoustics, ventilation, climate control, and lightings are adequately addressed. Because there was the underlying assumption that architects don't give enough attention to these practical matters in their designs. They thought it would be interesting to understand what is the state of the art, technology, and principles that are available when finally then selecting a design. So it was a separate select committee that was set separately from those responsible for determining the brief for the project. And the other thing that's really also quite interesting is that the brief did actually mention very briefly in the requirement that lighting and ventilation should be given serious consideration in the design, in the architectural design. So in that committee, David Boswell Reid essentially laid out a principle of how to ventilate the Houses of Parliament in that. And his proposal that he put forward was the most detailed one of any of the other ones. The other one talked about more general principles, but he came along with sketches and clear ideas of this idea of a stack ventilated debating chamber, for instance, where all the air would be introduced through towers. Then it would be able to heat it, cool it, and control and regulate its humidity, and then let it into a room and then exhaust it again through another tower. So that idea that the building would be sealed so that external pollution wouldn't enter the chamber, that the environment could be adequately controlled and adequately ventilated. He designed this essentially as a sort of kind of prototype outlined in this select committee. There was a bit of reticence for them to endorse it completely, but people recognized that he had a very strong idea what to do. And what David Boswell Reid did after that select committee concluded, he built another model back in Edinburgh in his chemistry laboratory to demonstrate that his concept was feasible. And he invited members to witness it. So as a way of proving a proof of concept idea, so through a physical experiment, and then eventually, as Houses of Parliament was sitting in a temporary accommodation at that time, so they essentially, what the House of Parliament had burned down in 1834, they built temporary chambers and temporary committee rooms within the ruins of the burned out shell of the old Houses of Parliament. And those temporary accommodations were considered in many ways rather uncomfortable for both MPs and peers. So that particularly the ventilation, there were a lot of complaints from members, MPs, about the air quality in the temporary Commons chamber. So they eventually agreed to allow Reid to experiment inside the actual chamber and implement these ideas and test them at a much larger scale in the building that's actually occupied. And in that, what meant to be only really a short demonstration, then become a rather permanent element because it was running almost 15 years. And you could monitor it, and he essentially used those 15 years. He was in charge of overseeing the operation of the system, and then keep logs, systematic logs of those environments that members were experiencing, but also collecting feedback from those occupying those interiors.
So it was like an early mixed methodology of qualitative and quantitative data.
Yeah, and that's quite an important thing because it wasn't just a short terms. Today we're calling that post-occupancy evaluation, where we commission buildings, they get handed over to the occupants, and then there will be a certain number of years where they're monitored and refined. But what is remarkable of the Houses of Parliament is that this became a rather permanent practice. So where the environment was continuously monitored, so it was done by people at that time. There were no computer loggers, so people keep log sheets where they were recording temperatures, relative humidity, and so forth in log sheets, in paper log sheets, and they were also recording the kinds of feedback that they had received from the users of those interiors and noting them down in those log sheets. And large volumes of those have survived, luckily, so one can now reconstruct the environment conditions that people had experienced, but also understood how people reacted to them, how they perceived them. And that was really important because it helped Reid to develop his idea and making sure they work in practice. So the temporary houses were in some ways a test bed of his idea that he would eventually allow to apply to Charles Barry's design in 1840. So that 5 years after the competition, eventually the commissioners of woods and forests, were essentially government department in charge of the delivery of public buildings, were asking David Boswell Reid to take on the responsibility for designing the heating and ventilation of the Palace of Westminster.
So this was after the winning design by Barry had been accepted. What was the impact on the actual design of his work? You've talked, and the subtitle of your book, and you talk in the book about this idea of disruptive environmentalism. Were there radical transformations, or were these quite subtle? You've mentioned the towers, and you've mentioned the use of the stack effect and so on. What are the nature of the changes that are implemented in the building as a consequence of Boswell Reid's insights and data and his scientific experimentation? And what is the reaction of the architect? I mean, what is Barry's response to this? How does this play out?
Yeah, so that's a big story, really. So starting off with, I mean, Barry didn't actually agree for Reid to take on the responsibility of overseeing the development of the ventilation system. He had hoped to employ a mechanical engineer for the project. So that's really important just to note. But because his idea was so architectural in its nature, his scheme had a fundamental transformative effect on the external form of the building, but also in the internal use of the buildings, which are maybe less visible. So that you essentially needed a whole new basement underneath the building to bring air and condition air before it is let into each room. So each room it was a central ventilation system, essentially air being the original scheme envisaged the two big towers at the ends of the Palace of Westminster, including the clock tower and the Victoria Tower, to act as major inlets and distribute the air throughout the entire basement, and the basement being added as a new feature, and then send through vertical flues to each of the rooms within the Palace of Westminster, and then having another set of flues that would take up the vitiated air, the foul air from the rooms into the roof spaces and then convey them out of a central turret. So this was the idea. This was architecturally really bold, and it required Barry to redraw quite a lot of his floor plan, to reallocate uses to other areas, because he suddenly needed a lot of space to accommodate those air chambers, because some of them were essentially entire floors. So that's something to keep in mind, that these ventilation chambers weren't just about putting a few ducts somewhere. It occupied finally about a quarter of the entire internal space of the building. Some of them majority of them would have been in the roofs and in the basement, but then you also had intermediate floors, which were referred to as plenums. So where essentially the air could be conditioned. So under each debating chamber, for instance, you had multiple levels where the air could be heated, humidified, filtered, etc. Before it was then let through openings in the floor into the chamber itself. So it's an early form of climate control that was operated by people, because people had to be able to enter those spaces. They had to have the right ceiling heights. There are dampers in them that were operated by people. So all those things required Barry to essentially redraw a lot of its plans. So some elements, of course, are hidden within the masonry of walls, let's say, like vertical flues that go to individual rooms. Some of them hidden in buttresses. So all the external buttresses on the outside of the Palace of Westminster are ventilation flues. They're essentially an early 19th century version of the Pompidou Centre, but they're in a Gothic form. But then you have also internal walls that are, without you even noticing, that are permeated by these hundreds and hundreds of vertical shafts to bring the air to various locations where they were needed. So that requires an enormous coordination exercise to actually coordinate this concept with an existing set of plans.
It's incredible, isn't it? I mean, it's a remarkable thing. I mean, what is the size of the project we're talking about? The Palaces of Westminster these days, and I was just looking on Palace of Westminster website, they say that the floor area of the building is 112,476 meters squared, which for American listeners is 1.2 million square feet. I assume that there's been some expansion since the 1830s on the Palaces of Westminster, but we're talking about an absolutely giant building here.
Yeah, it's an urban block. One used to really see it as an urban block. And this actually, the extremity of the buildings haven't changed since it was built after 1834. So it has this 300-meter long front. So it's just to give a sense of that. It's an urban block, essentially. It's not really, it's essentially a cluster of buildings with a variety of different functions. But something one needs to also keep in mind, it was not only large, but it also had a variety of other different functions under its roof. It had residences. So originally, large parts of the Palace of Westminster were residences. Alongside a large number of these public spaces, debating chambers are probably the most renowned spaces within it, but there were a lot of committee rooms and also a lot of serving spaces, and like kitchens and so forth. So it's a rather complex building.
Yeah, it might sound like an incredibly stupid question, but that's kind of my job here, to ask the incredibly stupid questions. Why does it need an environmental strategy at all? Why couldn't they just have windows that open? Are there specific conditions within the building and without the building, beyond the building in the city itself? And are there specific processes and functions within the building that demand a level of kind of sealedness, that necessitate, I suppose, as you describe it, disruptive environmental thinking?
There's a very good question. So the first one is to understand that the environmental conditions of London at the time the building was built is different to the one we see today.
Okay.
People still complain about the air quality of London, but it is nothing compared to the conditions that existed at the time the building was constructed. So one thing I remember keep in mind is soot. The amount of soot, that was a visible kind of pollution. And there's some wonderful eyewitness accounts, actually, when the Parliament was sitting in the temporary chambers and had various offices. They talked about people opening the windows, and then after an hour, all their files were covered in soot. So one concern was to essentially seal the building up from the external pollution. So David Boswell Reid did quite a lot of studies understanding the air, the wind directions and so forth, and how pollution actually travels across London, where the sources of the pollutions are, etc. And his idea was to essentially have a sealed building with filters. So there's some fantastic photographs that show of a later period when the system was still in use, that shows actually the filters that were put in to filter the air coming in the House of Commons chamber. They were pitch black because of this amount of soot. So before the Clean Air Act in the 1950s, London would have been incredibly polluted. So that was one of the key drivers. A second driver is to understand that certain spaces, in particular such as committee rooms and debating chambers, could have very large densities of people in them who would sit in this environment for extended periods of time. And to provide an assisted kind of stack ventilation system, the assumption was that you could push more air through a room with this system than you could by just opening and closing windows.
Right.
So higher airflow rates, you would call it today. Because essentially what we need to remember is stack ventilation. They're using natural buoyancy of air to go up shafts and pulling air through at higher velocities, but they also had actually heat sources within those towers to help amplify this natural stack effect. So they had coke fires, steam pipes that were placed inside them, steam jets to help that air to flow even faster at times, because the natural buoyancy would vary in the intensity over time.
Mm-hmm.
So these are probably the most important drivers to actually seal off the building from external pollution. The other one is to provide the kind of airflow rates that you need to maintain good air quality within from the people, because people generate heat, the breeze, the sweat, all of that is detrimental to the condition in which they live. And the idea is that ventilation is able to deal with the internal pressures as well as external pressures and providing a comfortable environment, healthy environment.
That makes sense. And of course, everybody wore wool or linen or pure cotton, and those things, they hold moisture like you wouldn't believe. They must have been very uncomfortable. That's really wonderful background. So thank you for that. I'm interested in this Boswell Reid character and his work as well in terms of its position within architectural or spatial or environmental design in general at that time. Was he a unique trailblazer, or was his thinking part of a broader kind of turn towards this form of thinking in architecture and building culture? Were other people doing this? So
in some ways, none of the elements that David Boswell Reid introduced in the House of Parliament on their own were new inventions. I think what is radical about this idea is to integrate different ideas into one holistic strategy. So this idea of having a sealed buildings, essentially ventilated, but also integrated ways of climatic controlling environment as one holistic design, and applied at the building of this enormous scale and complexity. So that makes a building stand out from other buildings which are much more smaller in scale. So to have essentially a central system. But the interesting thing is that it would have, at the time when the building was completed, you would see it become a common practice for building to have extensive ventilation systems. So even on Whitehall, the buildings built in Whitehall, the kinds of new public museums built in South Kensington, the Royal Albert Hall, all of those starting to incorporate these ideas, although they were not necessarily direct descendants of Reid-specific solutions in the Palace of Westminster, but they reflect a general shift towards more technologically complex buildings. And you see that in town hall buildings up in the north, for instance, you find examples of that. Manchester Town Hall, for instance, where similar methods are suddenly get deployed and becoming well established. So even the law courts building, the new law courts building in the Strand, the Royal Palace of Justice, has a complex ventilation and climate control system built into it.
And later on, you get people like Alfred Waterhouse at Strangeways and Manchester Town Hall building in environmental systems using stack effect and so on and so forth. So it's obviously part of that. I guess you might describe it as sort of Enlightenment thinking, the idea of the scientific basis for acting and behaving, for doing things.
I mean, one thing that might be also worth highlighting is, Waterhouse, for instance. I mean, what's interesting is when you're looking at his work, so he worked a lot with engineers who realize these ideas, but what's interesting is that his own drawings are already setting out a strategy, so that actually architecture, thinking about something like the Natural History Museum, for instance, that is actually like the Palace of Westminster, has towers. It has a labyrinth underneath. It has flues within the wall, it's got openings within the wall. All those principles need to be fully integrated into the architecture. And Waterhouse is one of these architects who fully embraced these new technological ideas in his design, and being something that's already visible from the outset and embraced by the architect, rather than relying on somebody coming in and disrupting the design. They're there from very much early stages in the development. And I find that remarkable because you wouldn't assume that. If you're looking at public buildings in the 19th century, you're thinking of them as architecturally, significant buildings, but actually that is quite deceptive, because behind all that is quite a lot of incredibly sophisticated technological thinking that's actually quite advanced. quite modernist in some ways, that maybe the aesthetic of the building might not suggest.
That's a really interesting point, because there's this kind of, when we teach or when we understand or read about modernism, it's very rare that we come across this idea of the role of environmental thinking as a key aspect of modernist architecture, and that Barry's Palaces of Westminster, with the work of Reid, sort of foreground that turn, because you see it in people like Alvar Aalto's work, the sanatorium. You see this kind of idea of environmental performance integrated into the design. It's interesting to think about it as within its heritage as well. But I was thinking also about this idea of a quarter of the Palaces of Westminster. Did you say of the floor plans of the area of the Palaces of Westminster being given over to this kind of environmental strategy?
Yeah, it's a volume, the internal volume.
Of the internal volume.
Enclosed volume.
And I think that for me, that's just very, very striking when we think about the imperative of ecological and environmental design principles in contemporary architecture. I don't think anybody thinks about, and it would be a very hard sell to a commercial developer to tell them that a quarter of the volume of their building needed to be given over to some form of environmental control system. That would be economic suicide. So I just wanted to hear your thoughts about how, well, I suppose there's a chronology here. What happened to Reid's system? What has been the impact of rediscovering, through your research and your writing, the significance of what he did on the restoration? And perhaps as a final thing, what do we learn from this as contemporary practitioners?
So one thing, I think, to start answering that question, I think we need to acknowledge the fact that we shouldn't think about it as a static artifact. So the system itself, as it was completed under David Boswell Reid, underwent modification quite early on in its operational history. So one thing that this book does actually examine is the lived history of that system, essentially retracing over 100 years of actually what happened to the system over its lifetime, how was it operated, and so on. And what is evident on is that I would describe the system. So you could argue that David Boswell Reid's system was a failure. So as some do, without actually having ever studied those. But through my research, I would try to develop a slightly more nuanced perspective on this, and just really consider the system as a kind of experiment, a long-term experiment. Because when David Boswell Reid's system started to come in active use, so in the House of Lords, it went active. So in 1847, there's changes that Barry had done. Because there was a fallout between David Boswell Reid and Barry, that in 1846 led to a split. So Barry continued completing the House of Lords without Reid's involvement, which included the system that he had designed, whilst Reid was allowed to continue in the House of Commons and implement his system there to the end, and also oversee its operation for a limited amount of time. But by 1854 already, they decided to make a series of physical modification, and there was another select committee that set to review its performance, and members weren't satisfied, and they go through the gurney. There was actually another scientist, an inventor, to review and propose a way of modifying the system that would make it work more effectively, and essentially simplified the system, but still using all of the physical infrastructure that David Boswell Reid had established, the towers and so on, but essentially reversed its flow. So now where the air was coming in, the air was going out now. So the towers that were previously designed to bring fresh air in, the Victoria Tower on the Lord's End and the Clock Tower on the Commons End, were suddenly used as exhaust towers to get rid of the hot air from the building, and also get rid of any assistant fans that were part of David Boswell Reid's original design, where the supply was actually fan assisted. So they thought that was a way of simplifying the system, having it purely stack driven. And so physically, the amount of change that happens to the building was quite limited. So it's mainly, I would argue, mainly an operational kind of adaptation to the building that allowed it to be operated differently. And as the building then came into use, after that change, that system remained largely in active use until the Second World War. And there were some modifications. So in the House of Commons chamber, for instance, they did make improvement. They introduced new kinds of filters. They introduced new kinds of fans to help with the ventilation and so on. But overall, I would say that they always worked with that basic infrastructure that Reid had established. And one key moment that actually led to the system eventually being disbanded was the war situation, where there was a concern about fire spreading through the building. So during the war year, they actually decided to break up a lot of the ventilation flues to stop fire spreading between spaces in case infantry bombs would hit the interiors. Because it has happened to the Commons. The House of Commons actually burnt out completely. And they believed that quite a lot of the velocity with which the fire had cut through the building at the time was to that extent caused by the existence of those large open flues that run through the entire fabric of the building. So that marks the sort of beginning. And then it was after the Second World War that increasingly mechanical systems were retrofitted in, but in a much more localized fashion. And in some ways, that's still up to this day. The Houses of Parliament, essentially, the modern systems are an accumulation of localized solutions that were introduced into particular parts. So that, for instance, the House of Commons was rebuilt after the Second World War with a modern mechanical ventilation and air conditioning system. So that was a completely modern building for its time, and now considered its own environmental heritage. But other spaces, such as the House of Lords, which had largely survived and were kept in historic form, took until 1966 until it got an air conditioning and mechanical ventilation system. So it kept operating in a slightly more Victorian way up to that point. And then you'll find, in the late 1990s, for instance, mechanical ventilation, air conditioning would be introduced in the committee rooms on the riverfront. So quite late. And still there are a lot of spaces that are not actually fully serviced in that way. So that's really important to understand. And this, I think the one thing that's maybe important about is when there's interesting idea of how buildings learn, isn't it? This notion that buildings over time, buildings are not static artifacts in general. Building services are probably one of those elements that keep evolving more rapidly than other elements. Let's say the facades of the Palace of Westminster has remained largely unchanged, but these inners have changed enormously. And where this sort of evolution of technology and expectation and so forth, and this, what I find interesting over those first 90 years, everything was always building, going back to where it started and trying to improve on it, or consciously move away from it, but with an understanding of what was there before. So it was a cumulative changes over time and a gradual disengagement with the system in a area by area. So we know, for instance, by the 1890s, for instance, the committee rooms, for instance, had been retrofitted with local ventilation systems, who could operate completely independent from the rest of the building. And that is an example where you suddenly see in the facades new openings appearing inside the courtyards. So the courtyards were those areas where they were allowing much more change than in other areas because it would not be seen from the public side of the building. So you're suddenly seeing elements popping up through the facades and the more functional interiors of the courtyard where that was permitted. It is also in those areas that where you see shades being introduced, to keep buildings cool. You introduce canvas awnings were introduced in the exterior of the building to keep the interior cool. And these kinds of things raise really fundamental question about the nature of conservation. When we think about architectural conservation today, actually evolution is part of the heritage of that building. And it's the heritage of most public buildings in the 19th century. If you're looking at Buckingham Palace, for instance, is also an example. Like historic photographs, you're seeing that these garden elevations and courtyards had external awnings over them. to keep the building cool, because it was in the age before air conditioning. That was a way of dealing with opening windows inside the courtyards, because cross ventilation during the summer period and so forth. So, and that is something that sealed building idea, for instance, that Boswell Reid had originally introduced. By 1854, they started moving away from it. So they allowed some natural cross ventilation to be utilized to supplement the ventilation, particularly for cooling purposes in the summer period. So the chamber, House of Lords chamber, for instance, had large windows that were swung open, canvas awnings drawn outside to keep the building cool in the summer period, nor operated by staff that give you a lot of consideration to that thing. So the buildings are organically living kinds of entities that learn. Essentially, this building is a learning about how to deal with the fundamental question of how to keep a building cool or adequately ventilated. And those buildings who operate the building, so it's a building that was managed. That's one thing one needs to keep in mind. It's very different from a domestic house in that they had a team of people who are employed to manage the building. And some people was part of their role was to manage the building and so forth. So there was a collective effort of actually managing the building, much more than we would expect it today, where we're using so much automation. Very much people occupying, we're engaging with the building on a day-to-day basis in a more extensive way than in any modern building. So they understood their building and how it behaved intuitively. Of course, they had to do on a day-to-day basis.
Has Boswell Reid's thinking, been significant in the renewal of the Houses of Parliament currently underway? Has there been an attempt to turn back the clock to something that's more akin to what he had implemented in Barry's design? Or has it been to just put in better AC?
So that is, I think, a very critical question. So in the book, I mean, the argument I'm making actually is not to argue that the system that Boswell Reid established was a perfect system. But what I wanted to do is, rather than just simply dismiss it as a crackpot plan, I want to understand really the true nature of the challenges and so on that they were facing and what happens to it over its lifetime. And of course, now with the forthcoming restoration, it's a new chapter in that history. So I would argue. And we are open to that question, almost returning to what happened in 1835. So what are the technologies we have available today? Thinking that's prominent at this time. And how do we look at it again through fresh eyes today? And one thing that my research main contribution really is about, first of all, acknowledging the design of it so that it exists, and also had a big project a few years ago within Parliament to create a digital model of the entire historic ventilation system so that designers could start working with this. And this was part of because I'm seconded to Parliament, and it's now 8 years, still ongoing, is to seeing how this knowledge can be used to inform contemporary design thinking, where we think about modern technology on one side, but also how far can we utilize some of that intelligence that has been accumulated over the lifetime of the buildings to inform modern thinking. Particularly if we're thinking about our buildings design, let's say by Alan Short, like the Contact Theatre, for instance, one of his earlier projects, or Eastern Slavonics Studies building, UCL in London and Bloomsbury. We're trying to reintroduce these ideas of stack ventilation into modern building design, whereas where they were actually going the step and allowing larger amounts of space to be provided to accommodate this system into buildings. In the Palace of Westminster, of course, that's been inherited and it's in there in the building already. It won't be a turning back of the clock, that's for sure. But the main thing that part of the research is to enable that any design that's going forward, it's currently in early stages of the development, is that it's informed by this understanding of the system. This touches on a number of aspects, the ventilation, cooling, but also questions of fire safety. So this is an area I'm working on at the moment as a focus area, because the system, it wasn't only ventilation systems highly sophisticated, but Charles Barry also gave due attention to this question of how to keep a building protected from fire. particularly as you have got all those flues in the building. That is not a modern discovery that is a problem. Barry knew that from the start, that introducing those flues would stop building being easily compartmented, so that the fires could be contained within a room and closed off from the rest. So he had to think about ways of managing that risk of having flues going through walls and ceilings, etc., without undermining the compartmentation ideas behind the design that he drew on industrial mill buildings, etc., and tried to apply in a public building at an enormous scale. Mm-hmm. So all of those things. So one thing as in heritage buildings is what they aim as a research is actually doing is trying to bring a historic awareness into the way we're thinking about addressing some of these technical problems, mm-hmm. rather than seeing them as a modern problems where an historic building needs to be fixed and we just put something modern in. It is actually about developing an historic awareness into the thinking about a modern way approach to dealing with fire safety, ventilation and cooling and so forth. And in some instances, it will be about revisiting the possibility of introducing older methods of cooling a building that are more architectural. Let's say the idea of having shades on the exterior of the building in the summer period, which are not being used since the 1950s. But this helped to reduce, for instance, the cooling load. So even if it would be a retrofit of air conditioning, and lots of spaces will be, can the cooling load of that be reduced by introducing smart sort of approaches architecturally to reduce that cooling load by returning to some of those fundamental principles that the Victorians had used in a more modern way and integrated with a modern strategy.
What a great point to finish on, Henrik. Thank you ever so much. That was really fascinating and we learnt a lot.
Thanks, Ambrose.
And so it goes. Thanks to Henrik for taking the time to speak with me and for giving me a copy of the book. Please see the podcast description for links to it and to Henrik's professional profile and the project profile. And thanks for listening.